We had already an interesting day, but now it really gets interesting. Voices in Academia from the 5R Advisory Board, our youngest body within the 5R organization, within our ecosystem. The advisory board is advising the board of directors, giving inputs from research, from academia, and I'm very happy that so many members of this board have accepted our invitation to talk about data spaces, as all our event is about data spaces. Where are the gaps and where is the future direction? And all of this will be moderated by Stefano, our Chief Operation Officer. And Stefano, over to you from Berlin.
Thank you, Rick. Thank you, Rick. Good afternoon, everybody. So, very happy to yes, moderate these sessions. The agenda that let me go, since time is as usual very critical. I will immediately go into the presentation and the highlights of what we want to achieve with these sessions. As Ulrich said, the idea is to go to understand whether data space, how this concept is seen in academia and the contribution that can be given to this and the evolution of them. So the presentation that we will hear are from 6 of the members of the 5R Scientific Advisory Board. We will start with Joaquin, who will put together 2 important aspects: the aspect of democratization and the way technology can support that. As you heard yesterday in several presentations, several comments of the speakers, often is said it's not matter of technology, it's matter of governance mostly. And here we instead we join the 2 things and see how this will go far. After that, Benoit will tell us will bring us some additional issues concerning data spaces from her point of view, and then those issues by Antonello will brought into a specific domain that is a domain of energy. At this point, Antonio will elaborate and will propose an approach that could go and could support the solution of the issues that are posed there. Of course, himself putting again additional questions on the table. Luis will go over that and will bring ourselves in the real future and how quantum computing and quantum networking can support the evolution of a new stage of data spaces. And last but not least, Nejat will connect the research on artificial intelligence with that of data spaces, and we will see also this where it goes. So with these few words of introduction, let's definitely go into the session. And let me introduce Joaquin. Joaquin is professor at the Universidad Politécnica de Madrid and is with 5R since many years, even because 5R was that name. And so, Joaquin, the floor is yours.
Thank you. You have, okay. Thank you very much for the invitation and to this. It's an honor to be part of this group and to do this presentation. Here I will present our idea and our research. You must take into account something that an old professor told me a lot of years ago, the difference between the academia and the companies. In the academia, we do something that nobody has done before one time, and the companies do the same thing then several times, and they are able to repeat. Here in data spaces, the academia still have a lot of work to do. because, as you are seeing, data spaces is a great idea, is a great vision, but yet have to be fulfilled and solve a lot of technical problems. Here is where we see the place for the academia to solve this kind of problems. Especially, I see that there is two kinds of things. One is related to infrastructure. I am more researcher of infrastructure, so in the protocol levels, and in this way, there is a lot of things to solve that I'm sure we will solve. Will be a great solution. But also, I have identified that there is a great problem sometimes when you face that. Let's say you have a problem, you have a lot of data. Imagine you have a data space, for example, for medical, for doctors. And sometimes these data experts are not experts in, let's say, data and data engineering. So when we want to build data spaces, I think that the FiWare vision is really the path to go. There is a lot of technical things that are inside FiWare that can be parts of the solution for a data space. It probably don't cover everything, but there can be other things that are there. But all these kind of technologies sometimes are hard to handle. Well, technology that are being in research and now is beginning to work, and sometimes people that are not, let's say, data scientist or data engineer or a DevOps are not able to handle this. The key point for this is that we make all these tools and all these facilities able to be used by the experts in the area for the data space. For example, in the case I mentioned before, we are trying to make it available for doctors and try to simplify as much as possible the things that they want to do and how they can access data and all these kind of things. This is the key point for me for all these kind of problems and solutions, because there we can have really the way to go. If we build something that is wonderful, but this kind of final users are not able to do it, it won't get the data to the right ones, and probably we are not in the point. FiWare is great for this, in other, because NGS ILD is a great solution to join a lot of different data models and other technical things that I don't want to enter. I just want to mention that we are working on this and we are trying to find a solution that solves this kind of thing. We are doing some experiments, but probably we need quite a lot of research and connections to the data spaces. Also here, the context broker is the most easy or more natural way to connect to different data spaces probably in the future. The future will tell, but for me, this could be a solution. I just will now show part of our actual solution that probably will change in the future, and we will see how everything evolves. This is a solution that we are already trying to deploy in some hospital, and there we try to join different things pre-configured in order that the doctors use something that is, a component that is based on something that goes Apache Stepring. I don't want to go into this. But as I mentioned, the connection with FiWare via the context broker to the data spaces, and also that all the data is in an NGS ILD model will help that they don't have to care about connections and databases or these kind of things that are quite important for the data engineers, but not for the doctors that want to use this data. Also, we are trying to make easy to deploy even in the organization, because sometimes, as you mentioned, the governance of the data is quite complex. It's a problem to be solved. They don't trust it yet because we don't have yet the definitive solution that we can show to them. So our solution right now is to deploy everything inside the infrastructure. We are not moving the data. We are just trying to build the data space from the data that they have. And in this way, we are trying to obtain the trust for this kind of things. I don't want to enter more in detail because we don't have many times. Thank you very much for let me present this vision. And the key idea is that we should not forget the final users and the experts in the field of the data space that we want to build.
Thank you very much, Joaquin. As usual, quite inspiring. Let me, before giving the floor to Emma, let me say two things. First, as you see, this session is organized in scientific pitches, certainly not lessons. So you will hear short and strong statements from all the speakers. And then the idea is that after these speeches, we will have almost half of the time of the session open for questions from all of you to be discussed together. So I think I already a couple of questions in mind, just only after the presentation of the pitch of Joaquin. So hopefully other colleagues here around in the session will have the same. So please, for the audience, the floor is also open for pushing your questions, either in the question and answer or in the chat, so that we will collect them and we will go also answering your ideas, your points. So next speaker is Enoi. She is director of the AODG, the R&D director. And well, not losing too much time, Enoi, the floor is.
Thanks, Stefano. Today I would like to talk about how we could apply the concept of the data-driven networks for our data space more scalable. This is also the conceptual idea, and I would like to discuss with you guys how we could apply this. Thank you. The next slide. This is just for bringing your eyes that we have. Most of us are working for the European project, and then we know that for the making data space, we need to make a data interoperable, and most of the project probably would take the similar approach like my project of the NIADES system water sector, and that it's the one project itself make a data is with a common data model and the interoperable, but basically the one project cannot work for that, so that we work together with the synergy group in the same sectors. I think many other sectors are working in this direction, and then what we see the GaiaX and DVDA and all this initiative is working on this direction. Next, please. So basically what we want to do with this interoperable data is that we want to integrate for the new services. So when we make raw data to the interoperable common data models and then interoperable with the semantically, then this is a very easy to make a new services, and then even the cross sectors, that's what we want to achieve on the data space. Next, please. So that basically when we want to combine the data and then make an integrated service, we cannot go every data owners and then find a way to use it. So what we want to achieve is we make a semantic query, and for example, the air quality of the CTA, where is where I can get the certain data, and then basically the results should come where it is. Next, please. What we so far did in the European projects, we build a sort of the data marketplace, or what we call data center, and then data owners subscribe there, and such a data through the certain place that provide to the users. But when we talk about the data space and how make all the open data is available for the data innovation, how to share such a data, probably this is not very the scalable cases. Next, please. So that what I brought here to discuss with you, to brainstorm, is the the IRTF has a long concept of information-centric network. Of course, that's not exactly fitting to our data subscription models, what we are doing here. So we could think of how we combine such a concept. So there is application-independent components if we designing, like naming is not important here. I just call it data sharing routers, data broker, data switch, whatever we call it. And then such things has a very small set of information in their procore, for example, IP header, and then mostly we need the data names for prefix and the data sharing rules and access rules, and then this it would be necessary. So for example, the one data marketplace or data center A and data center B, and then when they want to link together, then they could register each other and authenticate together, and then they exchange the rules. And basically in this way that they know that when the data owner join to some certain place, you could add the data replica point in there. That's the probably that we could consider. Next, please. In this way that when there is a query, like a semantic query, like what we saw before, very simple one, but still if there's such things, and then not the whole the marketplace backend part, but there's the simple agent of the DSR sent this request to the connected DSR, and then with this small routing path that they could find the closest part that we could bring to the users. So somehow this is the concept that how we could bring the different marketplace or data centers together in a different sectors, what we are now making. Next, please. So basically, what we do not have in our TF is not yet, we do not have a common ontology or package for data sharing and access rules. So who is allowed to view this data, and then who is allowed to use it, and then how it may use it. And when it's a certain place, when you replicate the data in network replication or the other place for new services, such a replication should be possible, but the in which way is allowed and how much of data is allowed, such things as I think we could think and then make the in a very simple, short data packets, and we make it the open APIs for the what we now have, like a finding and then respond and in such a way. And then users' point of view, they do not need to be a member of the every single data places, and they could join one place and then make a query, and then with this kind of agent returning the answer, so that the users could get the wider range of the data. And then I think that's the way we maybe think of it, how we combine the currently existing technologies that but it's not fully fitting, and then we could think of it. Of course, I saw that the IDSA they have a concept of data broker and connector, but they do not have a full spec yet. So we have to see how much of the concept is fitting here, and then can think it together. Thank you very much.
Thank you, Anna. Thank you very much. So yes, again, I please put your questions to discuss in the panel afterwards. For this is open for all the attendees. So yes, the next pitch is from Antonello Monti. He is professor and director of the Institute of Automatic Complex Systems at the University of Aachen, and director of the institute there. So we will bring us in opening and brainstorming questions from the point of view of a specific domain. So all the open issues that we can see from there. Antonello.
Thank you. I think you can see my slide.
Yes.
So, perfect. Title I gave is Software-Defined Energy Networks. So goal of my presentation and my pitch, let's say, is to show that this discussion about digitalization of energy, so that our energy also is involved in the discussion of data space, go deeper in the energy system as compared to what people normally think. Let me start with some old picture. This is the first real power plant that was ever developed. It was at the end of the 1800s in the Buffalo, New York, actually at the Niagara Falls, when the first renewable-based power plant, because it was based on waterfall in Niagara, was developed. And the fundamental message here is that from that day, for about 100 years, the power system was mostly an electromechanical system. So we had basically what I can call a free flow of energy governed by very simple law of physics that will allow to connect all across a continent, as in the case of Europe, those rotating masses of the generation units in a synchronous operation. That is what makes our power system still today. But what we have now is that more and more these things are substituted by something that look more like what you have in this picture. What you see here maybe is not that immediate, but is a high-power power electronics system. Power electronics is what is making the system at the hardware layer also digital, because power electronics manage the flow of energy through a set of silicon switches that can be switched on and off, so in a digital form, many times a second, and in that way, they can determine with high accuracy how the flow of energy is going from one point to another. What that means is that while before we were letting the flow of energy to be driven by some fundamental principle of physics, now everything is driven by software and control solutions, which on a nutshell could be, in my view, a good news, because it means we have the freedom and the possibility to completely rethink the system and to define what are the basic principles of structuring the system. And what we have at the end is a very complex multi-layer software architecture that is emerging, because at the device level, you have power electronics, as in the previous picture, and we have a one level of control that takes care of this first digital layer. Then those things will be locally orchestrated by some edge systems. So cloud solution with an edge structure will allow very fast closed loop operation, maybe, let's say, coordinating the operation of several of those devices in the street where you live. And that's what I would call local control. Then aggregated in a more system level control that can be country level, for example, or even continent. And this is more going in the direction of cloud. And then we need to build a system of system coordination. That's where the business layer happens. And that's where more is the type of cloud federation. So it's an extremely complex system that is emerging, that with very high level business use case that are determined at the level of cloud federation. And right now, thanks to fiber technology, as explained in a talk yesterday, we are making this possible all across Europe with standard connectors based on NGSI and fiber technology. And then we ask, the question is, how is that going down the layers? So I think we are kind of coming to solutions at the upper layer, but still a lot of work can be done at the lower layer. So I synthesized here some key characteristics of this change. We have now the devices, whatever are those that we connect to the network, can play a different role depending on the conditions. In the old fashion, that was totally hardware driven, we had one box, one service. So whatever was a generator for the rest of the life, and that was always the case. Which means that we can think completely new principles of operation that are defined by software. So before we had some clear and simple law of physics that were driving the synchronism among all the units. Now everything is software created, and which means that classical synchronism is not anymore, or will not be, at the end when we have more and more power electronics coming into the system, necessarily the solution. That's why also, more from the electrical engineering, we don't see only alternative current, but also direct current as a possibility for the large networks. And every device then can play an active role. Before we had active solution, active system, the generator, and totally passive, which were the loads, strictly connected and fed with current. But if we make this, it means that any possible device in the network now will have and should have a data exchange. And that means also that we don't have anymore even the distinction between source and sinks. That was really clear. I think all of you heard about prosumers, and that means at home level, everybody can now become an active generator for the network, or in given moment be active simply as a load. And the flexibility of the Powertronics will allow the same interfaces to switch your role without any change in the hardware. But that means we're building very complex systems, and this complex system will be data-driven. Data-driven also the algorithm, so that the classical model base, when we with simple, let me say, law of physics will define the model, will be really challenged. And data needs to cross disciplines because this interaction will happen in other domains. Easier to think within mobility is mobility, but it is not limited only to that. And that's where data spaces are vital to make sure that this everyday operation is possible. There are some key challenges that are driving also the research at the moment. What is the best way to build a data-driven energy system? It's a revolution in the way of thinking. Right now, we are more in the transition and trying to keep the old principle valid and forcing the new devices to behave like the old one. But then we need a lot of new things, like interoperability is becoming more and more complex because it's among software, not anymore about electrical devices. And of course, in a transition, the transition path is one of the most critical things. How we insert new principle that will fully exploit the software-defined system while keep the continuity of service of what we have today. We will not switch from day to night. We have to make sure the new technology and solution can penetrate in the system without perturbating the system as we have it today. So that's, in a nutshell, I try to give an overview on how digital means and data means for energy beyond the more classical things people have been already analyzing for quite a while, and understanding goes deeper down to the hardware level. I thank you for your attention.
Thank you, Antonello. Thank you very much. Next speaker is Antonio Scarmeta. He's professor at the computer science at the University of Murcia. Yes, as we see, he will also add additional questions, but in a sort of evolutionary way to provide some approaches, solutions to questions before. Thank you, Antonio.
Hi, Stefano. Thanks for the invitation, and thanks obviously for all the public that is now attending us in the conference. So I more than a solution, really, as Stefano was saying, I mean, I think that there are several issues that need to be considered. That's why I put it here like a challenge, and obviously I put some kind of opportunities, basically, if you like, that we can have on this kind of new scenarios. So the important thing is that when we are talking about data space, we are talking about, I mean, several stakeholders, if you like, that are involved. You have data providers, you have data consumers, you have intermediate, and all of them need to have a kind of agreement, in order to share and to exchange this data so that it can be managed in that sense. So if you look at that scenario, and if you vision that scenario as already was presented, the evolution of the network, and I think it's very good what being behind the previous presentation, it is clearly creating a new level of complexity, if you like, to this problem. Because now we need to take into account that more and more different elements are going to participate or can participate on the processing of the information in that sense. So our data providers, our data consumers, and our intermediate are exploding in some sense in many different ways. And this is basically because of the new technologies, not only because of the IoT, but also because of the 5G technology, or 6G, if you like, in the future, is able to provide of this distributed processing capabilities, over all the continuum in that sense. So that means that we have much more a high number of entities that are able to participate on this process of data management, I say, in some sense. So we are moving from a situation where in some way the cloud providers, if you like, or the cloud entities already were becoming like a silo, where basically they do the processing, they manage the data, and they provide the service. Where now, I mean, the services can be provided everywhere. That's mean that the processing and the data provision need to be also expanded over all these space. So that's mean that also create a new kind of challenge, not only because of the architecture, but how to coordinate all these processing nodes in some sense that you can have a different layers. No, it's the same way that already was presented regarding SDN. SDN is focused on the network management in the sense, but now we are thinking about not only about the network management, it could be also the processing, the orchestration of the service provision that is going to happen in many different places at the same time. That's and with different capabilities and possibilities, as we are putting here, it's a quite heterogeneous scenario. And because of that, that will imply at the same time that all these elements that are participating on the data space ecosystem need to be agreed on the way how the data is going to be shared, on the interfaces, on the data models, and in that sense, that is what Fiverr has one of the key potential aspects, no? Instead to provide the possibility and the solution to facilitate, in some sense, to provide enablers that at the end are supporting this kind of distributed scenario that we are having in that kind of step. No? Also, it's very important that in the research perspective, this is creating a quite, in some cases, like an old problem that now it's being recapped again in a different context. No? How to coordinate, distribute, and how the intelligence can be managed on the decision making on this kind of complex new scenario, where you have multiple actors, where data now it is flowing from one part to another part of the infrastructure in order to be processed and maybe in different steps, for example, in that sense. So how to manage the data life cycle in all this process. No, as I said, we have now consumers, we have producers, but at the same time we have all these intermediate elements that are going to maybe to do some kind of processing over the data. And for that, specifically, the data sovereignty and the trust that we can create on that scenario is quite important, because at the end, you are moving, I would say, on all this process. We are not only moving, I mean, the devices that we are use it now, but also to move the data linked to the process and the services that is that are being managed on that mechanism. No? So it's quite important, the contextual management, I would say, of the information, because the information also can be processed in a different way in different kind of context. No, it's not same one that when you are talking about something that you have a control, where you have a big trust on it, whether maybe in other one where you have a certain level or reduced level of reputation. So there's a lot of different aspects that need to be taken into account. As I already said, it's important that all the agents coordinate the way they are going to manage this kind of information. So one very interesting point that, as I already said, already have come again on this kind of scenario is how to produce some kind of computing offloading in certain processors, because we have many devices now. We have devices with reduced capability and so on. We will need to have more and more the possibility to transfer and to translate certain part of the processing and the data, or the data, depending on the scenario, to a certain element that will contribute to do some part of the capabilities that are not possible on this kind of device. No, for example, in the case of autonomous driving, more and more it is being conceived that part of the processing of the video is going to be done outside the car, and that processing needs to be done in a real time. And with security and privacy, because at the end you are providing information from the drivers or the context of the driver in some sense. So it's important to be able to take this aspect into account. I mean, here I put some of the impact, not only about data, say delay sensitive aspect, for example, that we can have, but also I think more important, how to decide what kind of processing, how this process is going to be carried out, like pre-processing in some case, context awareness in the other. So there's a lot of aspects that are linked to the data that is going to be part of a clear element on all these first object of all this processing. That's it. So at the end, I mean, this just gives some concepts idea behind that is, I was at this, in this scenario, clearly, and I think it's also similar to what already was mentioned about the ICN. No, we are recovering some part of the ICN concept. No, the important thing is the data. No, where is the data is. You don't care what is the processing. Sorry, that you need over the data, not where the data is already. And for that, we will have more and more mechanisms, like based on local processing. Supporting of decision support system, intelligent tasks of loading, as already mentioned in that sense, and either on that, more and more on device artificial intelligence mechanism in that sense. So for that, we have a lot of solution already that you maybe all know in that sense. TinyML, for example, federated learning that is quite active. A lot of work now doing in that context is able to manage and process part of the information. And what I already said in that sense is the importance of the capability to migrate the information. Not only necessary the computing resource, because at the end, more and more it will happen that there will be specific nodes on the infrastructure that will be specialized on doing specific processing. And that's all. That's my last presentation, my last slide from my side. Thanks.
Thank you very much. So yes, the next speaker is Luis, professor at the University of Cantabria. Well, please, I will shorten my introduction because I would like to leave more time for the panel. So, Luis, please, you're muted, Luis. You're muted. You're muted. Luis, you're muted.
Now should be okay.
Okay.
Now it's okay.
Yes.
Can you see my screen?
Yeah.
Yes. Yes.
Okay. Okay. So just also I want to insist. So many thanks for, let's say, this nice event in which we learn a lot. So this is the first issue. And also thanks to all the attendees for sharing with us these 60 minutes. So I will be very, very brief. Also in terms of matching to the schedule that we have allocated for the presentation. So my intention here is just to provide some insights, or more than some insights, some thoughts on what are the implications of what we call quantum computing and quantum communications. And this links to what Stefano has been saying at the very beginning of the presentation, saying that, okay, technology is there, it doesn't matter, the issue is the government, etc. And I mean, I partially agree, but also I disagree. I mean, precisely the point is, the technology is not the issue because the technology is there. And of course, the democratization and all this stuff is becoming more and more important. However, I think that now we are in a quite challenging period. I think that we are lucky, once more, that we are living in a, I tend to say, in the next 10, 20 years, we will be living in a period in which many things will be changing in what refers to what we have been using, studying, researching, etc., in terms of, for example, security. So it is very well known, right? The RSA algorithm, based on the factorization of big prime number and the impossibility to do it with the traditional computing capabilities. And this is the fact, right? So the fact that RSA is based on this Euler function, etc., then makes quite difficult to break a number of 3,500 digits, for example. That was all. If you realize, most of the assumptions that we have are based on this, for example, in terms of security, but also in terms of search and algorithms. So in quite iterative mode in the presentations, you have mentioned the issue of having mobile edge computing needs, and the fact that, for example, EUNA looking for a specific data, this is time consuming, etc., etc. And this is because all of us, we have in mind the classical computing scenario. And then the point is that we are in a period, as I said just before, in which all this stuff is going to change. And indeed, it's already changing. And this gives me the floor for this very nice, at least I enjoy with this slide, that it's the first time that I have prepared indeed for such a fora, in which I put, or I try to reflect 2 or 3 key aspects related to quantum stuff or to the quantum mechanics stuff that will impact on the traditional way in which we are living telecommunications and computing, etc. In terms of computation, so the idea is that so far, you know that MP problems are not solvable in real time with the present computational capability, and this is the reason why, for example, RSA algorithm is still safe. But as you know, every year or every 2 years, we have to increase the number of digits of the algorithm, aiming at making it enough robust against potential attacks. So which is the reason for that? I mean, the reason is because the computational availability or capacity worldwide is increasing. And it's increasing, I tend to say that linearly. Let's formulate in that way. What is happening with the computation? In computation, it happens with quantum computation. What does it happen? So in quantum computation, the idea is that we rely on a very well-known concept for the engineers, for the telecommunication engineers, which is is linear, right? And the linear superposition. If you realize, once we had a traditional circuit with several sources, what we applied for solving and finding the current or the voltage or whatever was just the superposition principle, and then we have the Thevenin equivalent or whatever, right? So this is the basis in quantum mechanics. So the superposition of states. Those states, initially the most basic state is what is called the qubit. And what happens, so once we increase the number of qubits, what is happening is that we increase the computational capability of the computer. And once we, let's say, the computational capability of the computer grows in an exponential way, as it happens once we have a stream of qubits, then what does it happen is that what is happening is that we break, for example, the traditional RSA protocol, but also we break all the elliptic algorithms or elliptic-based algorithms that traditionally we have been using in many frameworks. So this is the first point. So this gives, let's say, or this gives a place for what we call, let's say, the BB84 protocol. Yes, I finished, which is being used or is starting to be used in some networks. And last but not least, from the communication perspective, a key issue or a key aspect that we have to put a lot of attention from the traditional engineers is what we call the entanglement, right? So this will have impact in the way that we'll be accessing to the data spaces, in the way that the, let's say, wireless networks will allow to allocate resources for accessing to these mobile edge computing resources in which we have the data spaces, aiming at making things much more efficient. So that's all, Stefano, and thank you all of you for, let's say, for sharing with us this time slot.
Thank you very much, Luis, for your inspiring thoughts. And last but not least, Najab, floor is yours to integrate data spaces and artificial intelligence for us.
You see my screen?
Yes.
Thank you, perfect. Again, thank you, Stefano, and thank you for all the audience to join us for this 1 hour session. My talk is about the use of artificial intelligence in smart manufacturing. This is a large topic that we continue to address, and we see how we can answer through the new AI-based solutions to the traditional user requirements in terms of quality control, in terms of product and machine preservation, in terms of the acceleration of decision-making. To address this, we take profit of the set of solution building blocks that we can identify from all what was released by FireWire, by other programs, and helping us to address different types of problems in terms of connectivity, in terms of the use of IoT devices, in terms of the distribution of solutions between cloud and edge, in terms of data analytics and capabilities related to the acceleration of the decision making. Here we can see from the AI4U project new integrated capabilities for data acquisition, transformation, model creation, solutions generation, integration, and acceleration of the deployment user Docker solutions. And from what was published in the IoT catalog, a lot of use cases where we can find structured methodologies helping to connect a set of transformation steps in order to answer to user requirements. All of these capabilities are used today in order to support the improvement of manufacturing processes. And in our research, we highlight the still open issues where we expect to increase the level of reliability of AI-based solutions. The discussion starts from what we need in order to build AI-based solutions, how to validate the capabilities of this integrated intelligence, and how to control the solutions later in order to provide a certain level of reliability on the system that we are building. I'm trying to represent the different works using this life cycle vision. So we are going from the research and development to the industrialization of products, to the production, the delivery, and the use. And here we identify different scopes where artificial intelligence is needed. At the industrialization stage, we are trying to use the previous experiences, the history of quality control, all the available data in order to provide the best practices helping us to answer to new feature development. And in this stage, it's possible to find evaluation of existing capabilities to select the best sequence of machines able to support the production of new products by analyzing, as I said, the different available data. Another topic is the generation of quality control gates. So you can see here the different operations related to transformation of product, the quality control operation, and the batch releases ones. This is a very traditional view that we have. And today we can, using artificial intelligence, find the best way to provide a sequence between operation and quality control. This is what we call the quality control gate. And this is related to the reliability of the previous operation, the history of the quality control operation, and the trade-off that we can have in order to increase or optimize the reliability of these segments. About zero defect manufacturing, quite concept that we can identify in the literature in many European codes. So the idea is to support the in-process quality control. So we are not at the end of the operation, but we are in parallel with the execution of the operation in order to stop when we perceive a deviation, find the best scenario to go back, improving or correct the problems and continue step by step in order to be sure that we will have the right product at the end of this operation sequence. So it's also possible to provide some adaptation or dynamic adaptation to the production sequences. So here we are, for example, identifying some critical problems with some industrial operation or transformation operation, and we try to split it into sub-operation in order to reduce the risk of deviation, and we keep the process reliable till the end. Additional scopes are expected at the delivery stage to monitor the delivery process. We can analyze here degradation risk when we have some data. And the very challenging scope is coming to predict failure at the user stage. So here, if you have monitoring data, we can do it. But also we can predict from failure because we don't have monitoring data, but we can analyze the failure and we can find the best cross-analysis that can help us to identify the reasons behind the failure, even without having monitoring data. So all of these challenges, we are addressing them. We are trying to reuse some of the software solution that I presented before and to build these artificial intelligence-based solutions. From the research orientation, so if you analyze what was produced in the last 10 years, we have a lot of research papers addressing some interesting topics related to performance, security, privacy, related to servicization of the solution, edge computing, edge-based operation systems, and so on. And all of this solution help today to, let's say, find the best orientation that we need to cover by that the build of artificial intelligence solution in order to support the manufacturing processes. So we find here a lot of, let's say, orientation that we can leverage in order to build the best solutions. The last point that I would like to cover here is the existing of a lot of ISO standards still structuring a lot of concepts related to the use of artificial intelligence for risk management, for controlling the system or the controllability of the AI-based systems, for quality evaluations, and so on. So all of them are very interesting, and they are providing a strong support in order to build AI-based solutions for manufacturing systems. Thank you.
Thank you, Nejat. My fault, I promised at the beginning a longer panel, but unfortunately, well, presentations were so nice, and so it was difficult also to chop them all. So next time we have also asked to our professor to be able to learn how to do elevator pitches, not only to teach how to do elevator pitches. But anyway, I enjoyed a lot. There is a question that I really would like you all to answer, which is, yes, here it is, which is connected also to my initial doubts and things. So, is data spaces just a politician buzzword, or data spaces have a role in the academia? And even as Yuri is asking, there is the possibility to see this in the curricula and as a research example. So 1 minute each, starting from Edouard, please. Although you are not exactly from academia, but also from a research institute, you have also something you may say here. Edouard, you are muted.
Sorry, can you hear me now?
Yes, please.
Okay. Well, actually, yes, as you said, that I'm not exactly in the academia. I'm a little bit in the middle with the industry and academia on the research side. Well, regarding the data space, I think this is a really, really broader concept. So each sectors have a different technical challenges we have. So even in this panels, we everybody talk in different areas. So I think it's of course it's not just a single research, that we have a very big umbrella as a data space, and then each side of the technical side that we are trying to solve the problems. I think that could be the very short answer from me.
Thank you, Antonio.
Yeah, no, I think that, I mean, at least from my perspective and my participation in courses in the master degree and in other one, I think in our case, it's already part of the academia, I would say, content in different way. For example, I mean, it is just to mention in one of the masters that we have about big data and IoT, for example, I mean, one of the courses that we are bringing is exactly about how to provide interoperability between different subsystems. And for that, we study and we work on the issue of definition of this connection between providers and consumers, and how to harmonize basically the exchange of data. No? So my understanding is that this is not it's not purely academic. Academia, it should provide and help us. Already was mentioned by Joaquin. New solutions and new ideas are bringing new proposal here, and that it will be clearly connected with what already is being required, I would say, by the evolution of the internet, if you like, in some sense. No?
Yes, Luis, it is to go ahead in the end.
Yes, I mean,
or really there is a role, or just pushing by this.
I fully agree with what has been already said by my two colleagues. So this is both academia and industry interest, and the point now is to work on that, to optimize, etc., etc. So I fully agree with what has been said so far.
Antonello?
I just can add that we are creating new masters that are able to bring together information technology and energy. And interesting is the professor with which are developing is the expert on data management, so definitely connected to data space. So my point of contact in the Faculty of Information Technology is exactly in this direction, which shows how that topic is in a way critical.
Okay, Jean?
Yeah, thank you for the question. I join my colleagues to confirm that data spaces today are already covered in most of the academic programs, as when we are, for example, teaching artificial intelligence project, we are splitting the different steps, and we argument the fact that we need additional data, we need additional stakeholders connected with exploitation of the new processes that we are building using artificial intelligence. So this is a must, because we are harvesting new sensors, we are integrating new systems, and the expect is to make use of this new data in order to create the value. Data spaces are already addressed in academia, or addressed in industry, because this is an added value that can bring new capabilities for decision systems, new capabilities to improve industrial processes, and new capabilities to create at the end of the process something that we cannot have only using available technical data in some companies.
Okay, Luis, sorry, Joaquin.
Yes, I fully agree with all my colleagues. And I think that even right now, there is no data spaces because the name is very new. All the concepts required to build data spaces are there. And for example, we are now in a degree of data engineering. Probably we will put some lectures or new signatures dedicated to how to build and handle data spaces. That will be a quite hard thing that will require a lot of teaching to the new people how to handle this properly.
Okay, thank you very much. Yes, we have 1 minute just to close, so well, not enough to have another round. So I will wrap up here. I think, well, all the attendees have enjoyed this session, I think there are a lot of other issues that will go forward just on top of this concept, the data space concept, which will brought some further thinking. Yes, of course, as just to say what Joaquin said now, Joaquin said now, technologies are there, but in order to go further, there are other aspects that should be investigated in order to have a successful adoption of these technologies and a further understanding of this technology. I have a lot of other questions, but yes, let's close here. We will organize certainly other sessions during the year, but also we will organize other sessions during the next FIWARE Summit. Will be in Gran Canaria 14 in September. So be ready for a much more deeper debate there on this kind of questions. Thank you all for attending these sessions, and the floor is for the next session. Please join.